So today I'm going to just talk about the infrastructure that we have at Vanderbilt University for Center for Structural Biology, or CSB, and this will help us. This will give us a foundation as we move forward in our data processing videos. So at Vanderbilt, we have a body called CSB, Center for Structural Biology, and this body is responsible for providing a storage called DORS, DORS. I don't remember what exactly this acronym is for, but DORS is an online storage for everybody on campus that works with structural biology. Actually, it's not on, it's local online storage. So you can use it only within Vanderbilt facilities. You can, it's not like Google Drive that you can use it from anywhere unless you're connected to a VPN. So DORS is online storage. Our lab, Iverson Lab, has a limit of about 100 GB. What does this mean is that we can store 100 GB of data on DORS. Why so less or more? Depending on which year we talk about, because storage gets smaller and smaller every year. But the reason it's this way because we have to pay for this online storage, and you really don't need a lot of online storage specifically for crystallography. Maybe for EM, and for that we have different solutions that I'll talk about. But having 100 GB gives us the flexibility of working on one workstation or one computer and then moving to a different workstation somewhere else. That data is stored on our desktop, and it will translate into any other workstation, so we can access that from any workstation. So basically all the files that you have on your desktop, on this on DORS, on your desktop or your documents folder, they will be same, or that will be uploaded onto DORS, and it will stay same across all your workstations that are provided by CSB. So all our workstations are managed by the CSB, or our computers. So workstations are computers that are built for data processing, and they're very powerful. So we call them workstations instead of just computers. But they are managed by CSB, even though they're bought by our lab. But CSB IT team will manage those for us. So CSB provides us DORS, an online storage system, which is a minimal storage system where we can save our files. We don't save our data on there. And once we reach our 100 GB limit, this could be different for different users, but in our lab, everybody gets a flat 100 GB of storage. Once you hit this limit, you'll get an email from CSB staff that you are reaching your limit, so you have to go and delete your stuff and make some room or upgrade to the storage, which is not ideal. So you probably want to delete some stuff from your DORS online storage. Then the other storage options that we have are our local storage. So we in our lab have a storage solution called T1. This is a huge storage system. We bought this for cryoEM data because they're bigger, but everybody can store data on here, and this is about 150 terabyte. Here for EM, we usually store our raw data, but you can also store crystallography raw data as long as you follow the folder structure so that the data can be found by anybody in the lab and can review it or view it or download it. So this is where we store our raw data, and we pull this data from there to different workstations as we do our processing. Now in our lab, this is connected to a 10 gig GB Ethernet. So if you're on campus and using, it's almost as having your own SSD space. So this is very nice to have. So T1 is connected to 10 GB Ethernet, so you can load all your data and do data processing from this T1 storage solution we have. Then we have individual storage solution on our computers. So for example, we have storage called data 1 and data 2. This is on Alita workstation. Then we have Spot data solution or the Spot storage on the workstation called Spot. And then again we have Ultron data solution, which is a SSD again on the workstation Ultron. We also have HD1, which is a much not older, but it is the one of the first data storage we have in the lab, and that is specifically used for crystallography, and that is, I think, on HAL, which is in the workstations. So Spot, data 1, actually data 2 is the one, data 1 is the smaller storage. These three are SSD storage on each workstation, Alita, Spot, and Ultron, and they are all 22 terabyte. That's the max we can go on the SSD. So we usually use this space, 22 terabyte, for data processing, so that it's on the computer, it's faster. Currently, we have been storing our raw data on here for the dataset that we process, but moving forward, since we have everything connected, all the cryoEM workstation connected by a 10 GB switch, we want to use T1 for storing our raw data and processing as well our raw data. I don't remember how much the HAL storage is, but it is probably some few terabytes, probably 10 or 12 terabytes, I can't remember. But it's a smaller storage than the rest of these. And then lastly, I'll talk about workstations. Let's see. Once I can figure this out. Yeah. For data processing. So we have our something called ACCRE. ACCRE is you probably have heard about Amazon Web Services, AWS, or Google Colab, and other similar online places where you can process. It gives you processing power, or like it gives you it's a platform where you can process, you can run code. Here to run code at Vanderbilt, you can use ACCRE. So what all these platforms provide is basically a Linux system with a powerful GPU. So ACCRE is Vanderbilt's own Google, Amazon, Vandy's. So ACCRE is Vanderbilt's own workstations, online workstations you can call them, and we use it to process our data. AWS and Google are a little expensive. They are a little expensive, but Vandy's ACCRE is cheaper than AWS and this Google Colab. But if you have GPUs on your own workstations, then that is even more cheaper. That's like cents. It's very much cheaper if you do it on your processor on your workstations. So we don't use ACCRE for our processing, but if you wanted to, we could use ACCRE. We have better GPUs in our lab than what is available at ACCRE, actually. Well, the good thing is we had GPUs, plenty of GPUs to process data, and they're available 24/7. On ACCRE, you may have to wait until the weekend to process your data. So at Iverson Lab, we get the flexibility to use our own, have our own GPUs to process data. So you can process 24/7. Quickly, I'll go through the hardware for the computers that we have, or workstations that we have, so that we understand what we have in order to process our data and why we need it. So Alita is our first cryoEM workstation, and then we bought Spot and Ultron. Spot and Ultron are exactly the same workstation, and Alita, it was the first one. So Alita has 48 core and 4 GPU, And the GPU this has is, I remember, if I'm not mistaken, it's 2090 Ti, which means it is each GPU has a RAM of about 12 GB, so 12 GB into 4, and the total RAM we have on the computer is, I think, 128 GB RAM. To compare this to our computers, for example, on my laptop I have 4 cores, I have 6 GB or 8 GB of RAM, and at best I have 1 GPU on a Windows laptop with 2060 or 2070, which is about 6 GB. This is a powerful workstation. On Spot and Ultron we have they're little more advanced, or bigger in terms of their processing power. Also on Alita we have 22 terabyte of SSD storage, and it's called Data 2. So that's where you're going to store for example, you call on Windows it's called C drive or D drive. On Alita it's called Data 2, where we store our processing anything that we store is stored to the Data 2. Now this Data 2, you can access it from home if you wanted to, as long as you are connected to VPN. So that's why it's important to know the name of the storage. On Spot we have Spot and Ultron, we have 120 cores, so which is excellent, because in cryo-EM processing there are times when we having cores really speeds up the process by multiple folds. So we have 120 cores on each of these machines. We have about 512 GB of RAM. That reminds me, we may have 256 on Alita. And then we have 4 GPU on each of these workstations, Spot and Ultron, and these are I think 1390, and which is 24 GB into 4 on each workstation. And again we have 22 terabytes of SSD storage, and each one on these is called Spot and Ultron. So Spot and Ultron, so this / is for accessing it using a terminal. So the big change here is the cores, which gives us the flexibility to use more cores and run the programs faster. But also here, having more GPU or having more space on each GPU allows us to process a much bigger structure. So for example, our lab has Flea F structure, which is about 250 angstrom wide. And then we have a Flea FGMN, which is about 600 angstrom wide structure. And then we have a JNK or FRDA structures, which are about 100 angstroms each, or about around 100 angstroms, 120, 100 angstrom. So on Alita I can easily process this one and this one. I can also process FLEF structure on a 12 GB GPU, but for processing something as big as 600 angstrom, which means I need a bigger box size for processing, I will need 24 GB helps get a high resolution structure, because I don't have to bin my images or fold my images, which leads to a low resolution structure. So, and also crashing of the programs many times. So something like a bigger structure, anywhere bigger than 300 angstrom structure, you probably want to use Spot or Ultron. Anything above actually 400 angstrom, I would recommend using Spot or Ultron. So that's all we have on the infrastructure that we have in our lab, Iverson Lab at Vanderbilt University. Going forward, I'll make some videos about processing the data and what different softwares we need for cryo-EM and crystallography and other things. Thank you.